take it away.
So today's lesson is basically a continuation of last week's lesson from Game Dev, where Jake taught you the basics of tic-tac-toe and the beginning. So I'll be continuing that right now. Of course, so here I already rewritten all of Jake's code, or what he has already written. So right now this is what we have right now, right? So now we want to continue with writing our code. So I will go through a little bit over what we already written and what Jake has written. So we have a variable to keep track of whose turn it is, who's the winner, whether it's been a draw or if there's a winner. We have the height and width of the window here for the game. Then we have an RGB value, which is like how much red, how much white, how much red, green, and blue there is that you combine to get different colors. So for white here, it just all the colors at max. And then we have line color, which is just black, so none of them. Then we have board, since at the starting value it has nothing, so it's just none. Then we initiate Pygame, we choose an FPS, we have a clock, we set the size, and we have a caption. Then we loaded our images here, but we haven't used them yet. And then we have set up a very basic game loop. So if we run it, takes a little bit, but see, now you have your Pygame, you have your Pygame window here. So we can just close that. So now we definitely want to do a few important things first, like how we need to we're gonna have to first resize our images, because right now they're not the size we wanted. They're a bit too big or too small for us to use. So right now we want to resize these images. So let's see. So we definitely want to rename these. So just making sure, right? You guys can see my images, see my coding window.
Wait, could you make the text a little bigger?
Let's see. Sure.
I don't know if it's
text size.
You go font size.
It's font size, yeah.
Yeah, large. Okay.
Yeah.
So then we have our new variables. So we have that. Oops. But you can see my size. Okay, pg dot image dot oh, sorry, not image. Oops, I am very sorry. So we choose what image we wish to resize. So initiating window. Then what we want, what are the dimensions that we wanted, which is width and height plus 100. Then do that similarly with the other one. This one is a little different. It's going to be 80 by 80 pixels. Okay, so now, yeah, so we have written this a little bit of this code to resize our images. So, and resize image to our usage. So we have this Pygame, and then we want to transform it and want to rescale it to what's rescale. So this is what this function is for. So this is which image we have already loaded in that we wish to resize. Then we have to make this little tuple here, which contains what the width and what should the height be. So this is what we're doing right here. So I want to explain what's going on. So I'll write a little comment for anyone. So now we want our game to like be a little more sophisticated than your usual tic-tac-toe. So we want, say, like a loading image. We want to say this image, this modified cover PNG, to show up on our page for a little while before we actually start playing the game, right? So we want to write a new function so where we can easily do this multiple times. So we write our new function, and then so we can call it game in. We have def, which defines a defines a function. This is a name, and since we don't need anything, we just do screen, which is our current screen, and then we do something about be lit, or which basically allows us to draw a new image on top of the existing screen. So what we want to draw right now is realize I did not do right spelling. So so we have this, and then we want where our bottom corner, so where our position should be, and it should be 0, 0, right? Since we want to cover the entire page. So we have our initiating window. Then now, since although we have drawn the image, it actually hasn't the Pi game hasn't actually updated. So we definitely need to do an update to make sure that it actually reflects what we've done. So we do Pi display, right? So now we have our new image, and now it shows up on screen. So we want to wait a while because we don't want it to appear and immediately disappear, or because no one will be able to see it, so it'll be pointless. So we have to make it wait for a little while. See, so we use the time import from here to force the game to wait a little bit until we can make the screen go away so we can actually play the game at that point. So now we want to get rid of. So we fill the screen with our white color that we defined earlier. So now there's no more of that picture, the initiating window. Then we have a few lines that we want to draw, right, to create the game. So we do our first PG.
Matthew, could you show us what the initiating window looks like again?
Oh, the initiating window? Oh, okay, sure. It looks like this image, right? So that we have defined here. This is what it looks like if you expanded it in size. So if we say, yeah, so this is what the initiating window would look like this image. Because that's what, see, remember when we defined it back here, initiating window as load this modified cover.
So it's kind of like a loading screen.
Yeah, so it's like basically like, yeah, you would call it basically a loading screen where it will load in an image and it waits for a little bit, and then you can start playing the game. So then once we actually got, once we finish loading, so to speak, and then we remove the image, now we need to actually draw the actual lines. So we draw a line, we have PG to draw that line, which is what our draw line is. That's how we draw a line. Then we want to write where we want to draw it. Sorry if you can see my, so where we want to draw it, what color we would like it, and then we draw. That's another one of our starting positions here. You can see where on REPL, it gives you a handy little description of what we just enter and what it actually does in terms of the so it's actually one of the where the starting position is. Then we need to write another one where it ends. So we had to write another tuple where it's supposed to end, which is 0, and then so you can think of this line as the top horizontal line that we draw. So now we need to draw the middle line. That's P. Similar, we write the same. We still draw on the screen, and then so we multiply by 2. So now we can get into the middle, and then very. I cannot type today for some reason. So we have drawn these two lines for the. We have drawn these two. Oh, I just realized a grave mistake I made. I realized I call these the horizontal lines, but they're actually the vertical lines. I am very smart. These are actually the vertical lines. So we have drawn our two vertical lines, and then we need to draw actually two horizontal lines. So now we have our new basic base, which is PG draw line, the screen, the line color, and then now we need to write the coordinates for the starting position, which is just we draw that for the second one. So there you go. So now we have drawn our two lines, and we have these two lines here. So now, we have our basic model for the game now, right? So we have our loading screen. Then we wait a little bit, and then we have our window here. So we can say call this function, which would that, and then try it. No, I'm very smart. I am very smart. Oh, oops. Sorry, it's not wait function. I am very good at this. See, so it shows the image for a little bit, then it cuts away to. Wow, I have to do a little debugging because I clearly made a mistake here.
Matthew, I think that's with the coordinates.
Yeah, I'm reading a. Yeah, it's definitely with the cord.
You forgot to do comma height on the first pair of XY.
Oh, yeah, I just realized that. See, very smart.
Debugging.
Very important. You gotta definitely read the error instructions to see what's going on.
And for line 6, there's 63 as. Oh wait, never mind. I think the other ones are good. Oh wait, no, line 62, right? Or
63.
actually, no, I think it's fine.
Oh yeah, sign there. See, now we have two. Oh, you definitely. So we have two. We have two lines and two horizontal lines and one vertical line. That's strange. Wait, that's really. Oh, I probably. So we have the loading symbol once again.
Now for the second vertical line, like both of them have my coordinate height, I think.
Vertical line. Oh yeah, I am very smart. So now here, boom, you have three, you have 9, or you draw on your lines, you have 2 vertical lines, 2 horizontal lines, and then now you have 9 different boxes that we can use, right? Although it may be a little too thin for certain usage of the game, so we can look at there's actually another thing we didn't enter that we could have changed. See, you see here, REPL tells us it's width of the, basically telling you how thick you want the lines to be. By default, it's 1, but we can make it thicker to say 7 and see how it changes the lines. See, boom. Now they're way thicker and they're way easier to see. So now, boom, we have our base game already. So now we just need to implement the clicking and all sorts of things. So we can stop, and then we need to move on to where, although a little disappeared, there's a bottom space. We noticed it, right? That was a little bit just kind of empty, that didn't have anything there. So we want to keep that as where we can tell the player whether whose turn it is and what's going on, like who should be moving at a certain time. So we want to write a different function that would do that.
Wait, Matthew, before you move on, could you explain like where you got the coordinates from for the lines?
Oh, okay. So here we have our vertical lines, right? So since we now divide our box or our screen into like 3 parts, right? Because we want to use a line to divide it into 3 parts. So obviously the first one would be width divided by 3, because that's the vertical line, the width divided by 3. So, and then where it should run from is from the top of the screen to about the bottom of the not all the way to the bottom, but about to the certain parts on top of it. So about height. And this is line width. And this is similarly, we do width divided by 3, except since we want to move on to the second part, where we want to divide the remaining parts into half, we have to do width divided by 3 times 2 to move to the split the remaining into also halves. So now we have 3 parts. Similarly, run from the top of the screen to height, or about 100 pixels below the bottom of the screen. This is still the width. And then we follow a similar concept, except this time it's horizontal. And we do height divided by 3. And then we move all the way from the left side to the right side of the screen. And similar with this, height divided by 3 times 2 from all the way from the left to the right. So that's how we really get the coordinates of this. So continuing on, we definitely want to create a new function called draw status. This will be a new function to draw our new function. So we definitely have to access the global variable here that we have defined earlier, which is draw. So now, after continuing that, we want to access global draw, and then we need to check if someone has already run, because if someone has already won, then we want to definitely write that out, right? And we want to say that. So if winner is none, so if we don't have a winner right now, then we just have our text be equal to which is the current one, upper, so make it uppercase, plus else, then someone already won, then we say if there's a draw, then we have text equals to
Wait, Matthew, what's draw?
well, draw is the variable we check to keep track of whether the game has become a stalemate, right? Where no one X or O hasn't won. So that's what we use draw for. So now we continue on, and then we define our font. This is what font we're going to write with using Pygame, which is P. So that we so this is what's going on with font. We're at pg.font.uppercase font, and so the first one is a path name. If you have any existing, say, font files, which you can use to write your own fonts, like say if you have Times New Roman, you can have a font file that you can access using this. But since we're just going to use their default font, we're just going to leave it for none and now. And then we want how big our font to be, which is in this case size 30. And then now we want to so now once we define our font and what our text is going to be, we're going to have to render it. So we do message equals pg render our text. So right now so we can see that here text, this is our message is equal to render, which is what we're rendering, and what the color is. And then we can, this one is a special, this is it's something I'll get back to, but it's basically one of the many variables you need to enter when you want to render this. So we want to keep moving on, and then we give this, now we have to do, now we have to create a black space or somewhere where we can see the text, because we want the text to be visible and not hard to read. So we want to fill the text at the bottom. So we do, what is our color, and rectangle. So and these are the different rectangle corners that we're going to be using here. These are the different corners of the rectangle. This is a we're creating a text box here, which get underscore. So here we're gonna use a text rect to get a rectangle using this using what we are already existing renderer, and then we want to use this center to center a line where it should be when we're gonna display this text. So now we just obviously add this we add it to the screen, and then we have to just update the display. So let's try it. Oh, sorry, I realized something. Whoa. Okay, I realized we didn't actually call it. So we should definitely call it here at the bottom when right after we finish drawing this, drawing the beginning screen. I believe Replit has crashed. This happens sometimes when Replit just suddenly start loading, and it will just continually load, and it will never actually run your thing the way you want it to. So you just have to reload Replit, and then it should be okay. Pretty annoying most of the time, but you'll get used to it. See, so now it's loading, and then boom, tic-tac-toe. Okay. Once again, I seem to have missed something. Oh, oops, it's not. Should be font. You want to render it through the font, so it's obviously not Pygame rendering it. You can see the loading screen, and then boom, here is X turn, and you clearly have what's going on. So we know it's X's turn right now, and I've added an extra comma, so that works. So we know currently our status display, our status clearly works. So now we want to make to the most important part of the game, where we actually have to, we would click and we actually get to see the add some new moves to the game. So now we definitely need to write on how we should want to do this. So we want to write a new function which checks when our user is gonna, once our user has clicked, what are we gonna do about it? So we're gonna write user click here. So definitely user click. So once we know the user has clicked, we're gonna use Pygame to do this. We're gonna do Pygame, and we can get the position of where the mouse is when they clicked it, and then we can use that to figure out in which box did they click. And so now we have defined x and y's where they clicked. So if x is bigger than, so we know if it's bigger than the, sorry, it should be the other way. If it's smaller than width divided by 3, as we know here from drawing the line, see, width divided by 3, and we know it's in, so if it's smaller than, we definitely know it's somewhere on the left column. So we can just define a new variable, which is column, so we know it's the first one. And then we do a similar thing for every other column. So x less than, the reason, also you might notice here we only have one condition. The reason we only have one condition is that we know since it's not in the leftmost column, that then x has to be bigger than width divided by 3 by itself. So we don't need to add any extra conditions to the else if statement or the elif statement. So it doesn't column 2. Then if we know it's just bigger than just the final one, then we can just call it column is equal to 3. So now we do a similar thing for the row. So if y is, in this case, it should be, I can seriously cannot type today. What is going on?
Yeah, I don't think you need to separate the if and the elifs with the line
I
break.
mean, yeah, I don't, but I guess just makes it easier to see. But I guess we don't need that. So now we have figured out, say, what row and column it is. But say if they click somewhere like in the box, say they clicked in the display status box, then we know it didn't actually click anywhere. So with a comment on when it doesn't actually click anything. So we have to make sure there's a situation where we know that it isn't being, no box is being clicked. So we just have, so now we have these, so now we have our row and column. So we have to make sure that now we have, so now we have this row and column. So if row and, yeah, so if row, we just say not equal to none, and column is not equal to none, and board, which is row minus 1, column minus 1. So now we have this little if statement. So we're checking, first of all, making sure that row and column are both definitely, so we're not none. So we have clicked on one of the boxes. Then we're using our board variable or board array to make sure that it's still empty. Sorry, so it should be is none. So we know now it's empty. So we can actually access the global variable, which turns, and then we can actually say, write this temporary function, and we just we can use the images we have and draw the X or O into it. And then we can and then we should have a second function to check if someone's won once we've drawn this. So now we need to write these functions. Since we call them here, we should write them before. So I think the most important one is definitely to write the draw underscore XO function. So this takes in 2 row and column. So now we want to draw these new variables, or sorry, not draw these information. So this is a lot of messing around with exact coordinates, and I won't go into too much detail about how we got the exact coordinates, but just basically we have written things and aligned them so they should fit exactly within the boxes. So first row, we have position X would be 30. So we have something like that. And then we do something similar for the column.
Where'd you get that 30 from? Is it just the offset?
So basically, yeah, the distance where you would have like for each box, right? So like you have to move the images 30 pixels inwards, so that would be the center point. So it'll be at the center point of the box. So the image of our X or O isn't like skewed and too much like touching the other lines or too much out of the box. I keep finding the wrong variable. Right, so we have to find exactly where our coordinates are. So now we actually have to draw them. So we would do checking. So checking if XO is like say equal to X. Oops. So I should have done this earlier, but remember we have used global variables to access XO and the board, because eventually after we draw it with a mark it down on our board that say this position has already been taken and there's some sort of square in it. So we do that. We do screen. So we obviously want we want to draw on our screen, and then it just draw on our screen. Then the position is what we have just defined. And then we make sure to change XO to its new designation, because they switch turns. So to I want to denote on the board that this position has now been taken by, oh, oops. Now I thought we have to actually move this before we change what XO is, because we have changed what change XO is. So we're gonna make sure the original XO is not changed. So we do XO. So there you go. So that in essence is a very simple check. Draw what our board is, draw a new variable for on our board. Sorry, draw our X or O on the board. So now we need to actually write our second function here that we also have defined in user click right here about how we need check when. So we need to write a new function here. Check when. So we definitely need to access global, which global board. So we need board. So we want to do this in 3 sections. We want to check first if all the rows are, if any of the rows produced a win, if any of the columns produced a win. Then in the third section, we want to check any of the diagonals. And this allows us to use a for loop. So for row in board, and we and said if, well, actually we don't know. So check for row. Actually, we should use a parentheses here to make it a little easier to read. And we want to make sure that this, although we checking if all of them are equal, if they're all just say none, we don't want that to be a win. So we're gonna make sure that say board 0 is not equal to none. So therefore, at this point, we know it's a proper win. So we definitely want to also signify, say on our winner here, that someone has already won. So we're gonna access it and write down winner is equal to, well, also we need to make sure we know who won. So we're gonna write XO. Then we're gonna have to draw this line going across where he, sorry, going across where he already won. So we have to go through this row. And this is gonna get a little complicated when in terms of, say, oh great. So I'm just gonna say, so we're gonna have drop on screen. And this, for this color, we want it to be pretty distinct from the existing color. So we don't want it to be white or black because that'll be hard to see. So we're gonna go with a bright red, so just red. And so we're gonna have to use a little bit of well, not a little bit, a lot of math to do this, but it's gonna be something like, so we start from so right now that's what the coordinates for what the what the what the starting position would look like. And although it's pretty complicated, I'm not exactly gonna get into how exactly it works because honestly, we're not. I don't really have enough time to actually do that. So this one's pretty similar, which is boom. So now we have this. We have our function to draw a red line through the winning row if there is any. So now, so we have to do a repeat for this, except for in column of the row. So we can literally just say copy paste this, except change up just for columns. So instead of this, checking if the first and second are the same, and then we need a second one to check the second and third ones are the same, and making sure not all of them are just equal to none. So we have to make sure we denote who's the winner. And we draw a new line. I should remove this files part so it'd be easier for people to read it. I have messed up my, oh yeah, sorry. I messed up my graph. That should be. It seems to have added an extra. But anyway, so here we have drawn our specific line for checking for columns. So now we need to write our final part for checking what the different rows there are. So, no, sorry, not rows, diagonals. So we can just write this. We're gonna have to write this manually. There you go. So we have board not equal, just as checking the column, make sure not all of them are equal to none. So we have current. Oh wait, shoot. I realized no, we're checking. We have checking for who's a winner, so it shouldn't matter whose turn it is. It just matter who have won. So we don't want to use XO in this case. I realize. Sorry for that's my mistake. Or 0, 0. So now we check our winner. Then we want to draw a diagonal line. So we do PG, draw line. Here we're drawing the color. I changed it a little bit to, give it a little more diagonal, a little different from just a regular win, because diagonals are generally hard. Well, it's easier. It's harder than general, just three in a row for columns or rows. So we just want to change up the color a little bit to, look a little bit nicer. Then we need to draw these. Then we draw these coordinates. I did not draw it within the parentheses. There you go. So now we've drawn our line. And then we can just do another one similar to this for the other diagonal. So there you go. We check who the winner is. Then we just draw a line. Line. Write the coordinates. Are slightly different because this is going in a different direction. So boom, so we have drawn these lines and we have checked for winner depending on each row, column, and diagonal. So now we need to write something a little complicated, but I think you can understand. So we're going to use an all. So we're going to check all of the within this. If the all function, I believe, checks everything in an iterable two or 1D array and returns true if all of them are the same. So we do all for this. Oh, sorry. So this may seem a little complicated, but it's just basically checking if all the boards have been, if everything in the board, so if everything in the board has been used, and we know, and we check if there's no winner, So we know at this point that there has to be a draw. So we can signify here and make sure we access it here. Okay, and then we have draw, and then we stat true. Sorry, and then we just have to draw the status again. Make sure so it now can reflect that it's it's the next person's turn. So basically, we wrote all our functions that we need right now. So now we just have to go to original game loop and then reflect the new things that we're doing here. So we check for every event that happens while we loop through this. So we know if event type, which means if for any of the events in there is equal to which is this mouse button down is basically the code for when someone click down on the button. So we know it's click down. Then we can check user underscore click because we know they've done something. And then if there's a winner, if winner or draw, then we can say sys.exit. No, we should at least let the people see. So we should do time.sleep for say 5 seconds, then we can exit. So once we have our code, this should work now. So we had to reload the page because Replit stopped working as usual. Let Replit reload. Okay. So now we can try running it. So we have our initiation screen. There we go. Okay, so with X's turn. So say I'm an X, I click the middle. See, so I clearly made a mistake here again. But that's why everyone's here to watch me make these mistakes. Okay. So we know it's in line 116 here. Oh, okay, I see my mistake now. So as you see, this is me this is a mistake I would actually make a lot, but I notice now that we're going through each row. So row is actually now a array of its own. So we can't call it row. We can't call board then row as if row was an integer because it's not. So we can just call row on its own. I see. I made this mistake. So since I know I made this mistake with row, then I have to go down or do this again with column because I know I made the same mistake. And then column. Let's try this again after I fix my mistake. So boom. So now when I click, boom, the X appears. So with O, okay, which it seems to have, I have clearly not. So it says here, O image is not defined. So I clearly have not, it should have been Y image. So here, it should have been Y image. So once we reload, X appears, O appears, X. And so I have clearly made a mistake here. So let's see what's going on. So I believe just checking I didn't make the same mistake, because it seemed like I made a mistake with the brackets, which is, let's try this again. A lot of debugging. So X, O, interesting. Okay, clearly I did not fix the issue. We're cleaning this up so we can do a lot of debugging. So debugging is really important, right? So let's try X. So we can check what's going on. Why is it we're getting an error? So we go to see, it says row 123 screen. It says only can concatenate list, not int to list. Okay. So I think it's clearly we do give it more. So we just, how about we just do this? So we know what this is. So we have this. So we have two, it's clear to me there's too many brackets. So we should just do it like that. And then this has a similar issue where I'll just, so then I'll copy all the necessary parts, delete it, and see what's going on. So
Wait, Matthew,
yeah,
I think column is a list, right?
yeah, column is a list.
We like we have pg.draw.line, and then there we have call +1. You're adding in a list to a integer.
Oh yes, I see what you mean. Okay. I see what you mean. Okay, so clearly I neglected to mention I neglected to see this, but it says obviously in this, when I do for call in board, it's just gonna automatically do rows, like say for the first one. So we can't just do for column. So we can just say for let's say Y in range of 0 to 3. So then we can have then we,
Hey, Matthew,
yeah.
do you think you're gonna finish soon?
Yeah, well, I mean, yeah, I think I can finish soon. I believe after fixing this, we are pretty much done with the game.
Because we should start the CCC take-up soon.
Yeah. So call, so we gonna have to do some more reworking where call is now not a list, but actually integer. So we have to do. Mhm. So making sure. There you go. So Albert has pointed out a mistake and let's see if we have fixed it. X.
I think you need to fix it for the other ones too, right? Because, for example, the one like for the row.
Well, we see a 1, yeah. So clearly Albert's right. Yeah.
Because we have the same thing for the row plus 1.
Yeah.
I think you just column what you did for row.
It's a I am very smart. I should have foresaw all of this, but clearly not very good at this.
Well, so what you did before was right, but then you just messed up the loop.
Yeah, I just completely messed up how you should write the loop. So I have to rewrite. Since I rewrote what the loop is like, I have to rewrite what's everything inside the loop is like. There you go.
You have to fix the diagonals as well, or the diagonals.
No, I think the diagonals are okay.
Yeah.
So let's try not center.
I think go to the other coordinate.
That's strange. Okay, O is 1.
I think you have to the clicking part, right?
So I've done something wrong. So let's see what it is. So it's not in check when here, it's in where I draw it. Has to be in draw XO.
Wait, was this an error?
No, it's not an error actually. It's just when you click on a box, right? The image will appear in a different box than you actually clicked in.
Okay. So are we checking with the click function right now?
So first checking what's going on. I'm just checking that draw function. Seems to be okay. So now we need to check the click function. So I need to check the click function. Maybe we can optimize this by changing this a little bit. Be less than just the width. This. Less than height. Not equal none.
Wait, does it matter that like the coordinates are different than the actual thing?
Well, clearly there's certainly some issue.
I think they're being transposed, right?
Yeah, they're being drawn on top of the existing.
No, it's like the when you click on one, like one thing, it flips diagonally, so it kind of interchanges the x and y coordinates, right?
Maybe it looks like certainly I'm doing something wrong.
I think maybe it's just your x and y are switched around.
For my draw function, possibly.
What if you just switched? Actually, I don't know.
Hmm.
Like, what if you just switched around the x and y in the click and see if it works?
Maybe I'll just say, just
No,
exchange.
like that, your line function is okay. Like when you draw the line, right? So I don't think it's your check win function that's wrong.
So it should be my draw. Where is it? This is my draw.
Where's the thing where you draw the x or y?
Here, draw the X. Oh, maybe I put them in, like you said. Yeah, I believe I put them in wrong order. Y should be here, X should be here. We end it and we try again. Yep, there you go. So we have fixed it. See, now it works perfectly as you would think. And then X can go there. O and X. Boom. So X wins. And then we have this line. And then after a little bit, it closes on its own. And then we have a tic-tac-toe game. Although I admittedly made a number of mistakes that we had to fix, but see, now it actually works. So if I try to explain my best for most of the parts, although here coordination gets a little more specific that I don't have time to go into, but for a general logic and Pi game, you should kind of like understand how it works right now. And then later after a lesson, I'll like upload the code so you can use it. And maybe if you want to try a little challenge, which is make this so when you finish the game, say you want to like restart and then the game just automatically restarts, see how you would try that. And then later on, I guess I'll put up an extra piece of code on how you would make an auto restart function. So that's about it for now. For
Is there a reason why, like when you click, like when the board, like there's that extra like 100 space at the bottom?
Yeah, there's an extra 100 space at the bottom.
Like what does that do?
Yeah, no, that extra 100 space is just for the status. So that's just space for the status bar. So you see, oh, whose turn it is, or if someone already won.
Right. Okay.
So yeah, that's tic-tac-toe.